Hi, I'm Gregory, the Managing Director of 12D Solutions. My background for this talk is I'm a member of Building Smart, founder and member of the Open BIM Alliance, involved in Building Smart international conferences, committees and expert panels, especially with the IFC Infra Room, which is defining IFCs for alignments, roads, railways, tunnels and bridges. I was a co-author of the Building Smart International publication, Model Setup Information Delivery Manual, which deals with how a civil infrastructure project should be set up for IFCs. I do attend all the Building Smart conferences every 6 months, which the last one was in October this year, which unfortunately had to be online. And that's where the IFCs are actually defined. Now, I'm a passionate believer in open data exchange formats, so beware of that. So I'm a very big advocate of IFCs. What is BIM? Unfortunately, it depends on who and what you talk to. So if you do a wide search for the literature and standards, you'll find that if you ignore all that fluffy marketing gunk, that the BI in BIM is building information, where building is a noun and not a verb. And although BIM is also about the process, all the objects for a building site. The other constant though is that the international standard for transferring data is IFC, and that's controlled by Building Smart International. So basically, from Wikipedia of course, Building Smart International is an international organisation which aims to improve the exchange of information between software applications used in the construction industry. And they developed IFCs, or Industry Foundation Classes. And Industry Foundation Classes, now this is a mouthful, but it's basically intended to describe building and construction industry. It's also a platform of neutral, open file format specification that's not controlled by a single vendor or group of vendors. So that's what they do. They look after the IFC format, and that's usually called Open BIM. So IFCs, they've been around since 1995, and the most popular version in use at the moment has actually been around for 15 years. It was released in 2006, and really they've been restricted for buildings and structures. Why BIM have got a bit of a push along is that the US government, the UK government in 2011 released the Government Construction Strategy, which aimed to reduce the cost of government constructions by 15 to 20%. So this is just, right deep in the global financial crisis. And Open BIM and IFCs was identified as one of the strategies to help achieve the savings. What this set up though is, and this was their sort of outline, is you had down at level 0 was just drawings, CAD. Then you had some 2D and level 1, which had some 3D data. And further on down the track, they started to do more total models. But in that, there was no roads, rail, tunnels at all. Now, I'm going to talk about two types of BIM, vertical and horizontal. But they're both civil projects. So why on earth didn't the IFCs to date in 2x3 cover both of them? So I'm going to look at the differences that had showed all the concerns. So basically, with a vertical project, it's confined to a small little area, usually a building site, and then you go on up. You use a local origin, say like a 0, 0 or a number like that, and you measure distances from it. So you have small coordinates. And the distances are ground distances. That means the distance you get when you use a tape measure. A rectangular grid is normally used for setting out things, and the objects are 3D with a volume. For a horizontal project, it goes over kilometres, even hundreds of kilometres. We have to use, therefore, world coordinates, which are mapping coordinates, and they're in their millions. We need that because you need to be able to place anything anywhere in the world when your infrastructure project for roads and things, because you just could be anywhere in the middle. You can't just take over the whole site that you're going to work for forever. The distances are what we call grid distances or map distances, and they're not ground units. So that's important. It's not the same as you get with a tape measure. We have to use linear referencing, where you use alignment and offset. Think chainage, offset, station and offset. And the objects are actually points, lines, tints, and 3D objects which have a volume. So we'll look at those to see what those differences have actually caused, what problems have come up. So with that vertical BIM being confined to a small area, a local origin and ground distances, what does that all really mean? It means you're working in a flat earth. So if you want to think about things, that's a flat earth, remember that. With horizontal BIM, you extend over kilometres and kilometres. You have to have a mapping system for the world, and therefore you use these mapping coordinates, and the grid distances is not the same as your ground units. So you need the earth as an ellipsoid. So that's a fundamental difference between the two things. Also, for vertical BIM, you have a rectangular reference grid, and your objects have 3D with volume. Whereas in BIM, your reference is usually used with an alignment and an offset's being used. As I say, there's all sorts of different types of objects, which points, strings, tins, alignments were not in IFC 2x3. Now, can IFCs be civil? Can IFCs be applied to civil infrastructure? Can they be implemented for all stages of projects? Because if you go to the Building Smart International talks, they talk about IFCs being used throughout the whole project. So if you look at your 19650s, it's got all these different stages mentioned. And what's needed over a life cycle of a project changes. Right at the beginning, up until it's actually constructed, you have a lot of geometry. Often after that, you only have lots of attributes. In fact, when you're going to asset management systems, sometimes they don't even take your geometry. All they want is a whole lot of attributes. So we're really worried about that early stage where it's thick on geometry. So can you also implement IFCs without cost blowouts? Because you really are trying to beat that project clock. To be a civil BIM system, you need to support large coordinates. You need to handle long and large horizontal projects using map coordinates, not local coordinates. You need alignments with transitions and things. You need linear referencing. You need helixes for arcs. Now, why on earth do you need that? Why don't you just need an arc in 3D? Well, that's not what we use in civil. A pipe is usually an arc when projected down onto the plan. Then your Z value runs up the side of that. So it's actually a helix. Not many people realise that. You need strings with diameters and without diameters. You have survey points, break lines, edge of roads and so on. Drainage pits and pipes. Null Z values. Now people say, why wouldn't you want a Z value? Well, if you're a surveyor or someone else, you don't want to give it a Z value if you don't know one. Someone might believe you. Cadastral information, that usually doesn't come with Z values. So you don't want to give one. A name and coding system. Well, actually, in Australia, we've used that from at least 1980, codes for all the strings and objects. You want tins for surfaces, like your ground surface. You need point clouds, since that's the way a lot of this data is now being picked up. You need polymeshes or trimeshes for 3D objects. And you want a hierarchical attributes for your strings, vertices, segments, tins, polymeshes, and so on. Of these, only 3D objects and some strings were actually in IFC 2x3. And so that's what's been around for the last 15 years. So Building Smart International were aware of this, and so they had a number of working groups looking at extending IFCs to civil. So they were working on roads, rail, bridges and tunnels. And what they realised, an alignment was deemed critical to all the groups. So an IFC alignment project was set up. An alignment was called Alignment 1.1 was the final one, and it had strings with more transition types than the natural clothoid and special rail transitions. It also had tins. And we're involved in that project with the main roads, and basically this is a thing where we actually had read in IFC alignment string with a horizontal and vertical. Remember, you can have horizontal without vertical, and also the 3D alignment. And we presented that in 2016. Then we continued on with this work, and you could again have strings and tins and alignments and the 3D objects that go with them, such as the road pavements. And basically that was in 2017. So that was alignment 1.1. And that's the whole thing written out again, read back in to show, yes, it's all there, properly. Now, what was the outcome of that IFC 4x1 project? Zilch. Although 12D Model and a number of software groups participated and successfully passed around alignments and tins, when actually IFC 4x1 was released, the traditional architectural BIM software vendors never implemented, and the industry was left stuck with a 15-year-old IFC 2x3. What do you do in such a situation? Well, a lot of people then start talking about digital engineering and wait for IFCs to mature. So what is digital engineering? Deja vu. Again, most people have no idea what it is. Luckily, Transport for New South Wales came to the rescue here and gave a bit of an idea of what it was. It says a collaborative way of working using digital processes to enable more productive methods of planning, design, and so on. And this is achieved by creating a common data environment, whatever that is, that aligns digital information, including CAD, GIS, 3D BIM, and so on. So we did at least have something about digital engineering. And they even gave lovely plots or pictures, and you can see up the top there, you've got 3D BIM model, which we do in 12D model, and next to it, you've got a whole lot of attributes, and those together are called 6D BIM. So 12D model straight away is doing 6D BIM. Now, do not despair though. Building Smart International has continued to work on the problem, and they came up with two things, the model setup IDM and also IFC 4x3. The Building Smart's model setup information delivery manual, what a mouthful, it was then restarted up and the project was started off again in 2016. John Mitchell from Australia was the lead. Then 12 nations were involved, including Australia, and I was part of that and produced a lot of the information for it. It spelled out what ellipsoids, projections, and map coordinates are, also emphasised that civil projects must be in map coordinates, and said the vertical and horizontal datums and the map projections are stored in the IFC projected CRS entity. So it's right there for it. And IFC 4x3 extended this to any CRS and map projection, whereas the early ones didn't allow all the ones. Similarly, it also said how a 2D helmet transformation could be used to bring small little area sub-projects, which are in flat Earth local engineering coordinates, into your overall map coordinate project. So you've got a small little one, and how does it fit with a big one? This is the big quandary, the big problem. And the required 2D parameters are stored in what's called the IFC map conversion. So all that information could be passed over if you brought in such data. It also pointed out that in one IFC file, IFC 4x3 does not handle multiple small sub-projects in flat Earth local engineering coordinates, because each of those sites needs a different 2D helmet transformation, and IFC map conversion, there's only one of them for the file. But this has been looked at by Building Smart International. There's, again, plans for more civil objects in IFCs. Deja vu. It looks a lot like before, but this time it's going to be there for IFC 4x3. So, actually, Building Smart International working groups have been very active for the last 4 years or more on IFC 4x3, and it's now in the release candidate stage. It should be ratified and published next year. And the IFC alignment is there, and it's actually been extended for IFC 4x3, and TINs are also in there as well. And linear referencing, which is not in the early one, is also in there. So most of those sorts of things we need are there. So, to be a civil system, what do we have before? Large coordinates, always been handled by IFC. Yes, you can have long, large projects and know about your coordinate systems and everything. You've got your alignments, you've got linear referencing, you've got your helixes. You could use an alignment for that. You've got your string diameters. With diameters and without diameters, you have to use IFC annotation. I know that's strange, but it is there. You can have drainage and sewer pits, null Z values. That's not directly there, but I think we can come up with a methodology so we can handle it. We do have names in there, although they're optional. So most projects you should be saying, I want those names not to be optional. You have to have them. We've got TINs, we've got point clouds. I don't think people realise how big they are. And polymeshes are in there from 2x3. And they've got heaps of attributes and things. And again, the tricky ones like vertex and segment attributes, we should be able to figure out how to do them in there. So, will IFC 4x3 be more successful? Well, I believe it will be, because one thing that's happened is the Open Design Alliance, which we're a member of, has committed to implementing IFC 4x3. And that means over 2,000 ODA members will have access to IFC 4x3 readers and writers. So basically that should solve the dearth of software problem that killed IFC 4x1. So with Civil BIM, the question has been, isn't really though, how is it going, but why has there been so little progress? And the answer is actually very, very simple. It's called history. When you had IFCs, and they've been going around since 1996, I think they started, they grew up in a vertical world and only needed to be addressed vertical problems. So the people involved in IFC were mainly working in vertical areas, for example, architects. And it was mainly then the architectural software that then was involved. And for buildings, you only needed to be flat earth and local engineering coordinates. So that's all they had to have. But the last 7 years, we have been trying to work on IFCs for civil. And to date, though, not many experts from the civil authorities and companies, and only a few surveyors have actually been involved in the nuts and bolts of IFC for civil. So that means the problem has still only been looked at from one direction, that of local coordinates. But it looks totally different from another direction when we're using a map coordinates. So our goal is to have your information in IFC that works for both viewpoints. Luckily, 12D model is already a civil BIM system. What is missing in an industry is general support and understanding for project setups and the IFCs that you can use for civil BIM in, say, IFC 4x3. So yes, BIM and IFCs can be civil. It just needs civil knowledgeable people to help specify the geometry and, importantly, the attributes that you want in there, because not every geometry is to be used. There's all sorts of weird geometries in there that you can't use on a civil site, and to demonstrate how it can be done. And you'll actually see in a lot of the talks in our technical forum, the people are doing BIM models now, putting all the data in, getting it around, passing it through, some fantastic projects. They're all though mainly using IFC 2x3 because that's what all the other software can only handle. So surveyors and designers, Civil BIM needs you. Thank you.